Very good afternoon to all of you. Myself Kumari Silky, Assistant Professor, IIMT College of Science and Technology, Greater Noida. Today I will give a small session on software engineering fundamental. Okay, at first, agenda of this session, software engineering, requirement, design, construction, testing, and project management. And second one thing is development methodology and overview. In development methodology overview, the waterfall development process and heavyweight methodologies. Now, we comes on software engineering. In software engineering, we discuss requirement, design, construction, and testing. Now terms becomes what is software engineering. We all have known software engineering is the branch of the computer science that deal with design, development, testing, maintenance of software applications. Software engineering apply engineering principles and knowledge of programming language to build software solution to used end user. It deal with two terms, that is software and engineering. We all have known software is set of applications, set of code to deploy a system to form a applications that we used. And what is engineering? Then all methodologies comes under this that apply on this development, that is engineering. And engineering also terms to invent new things. That's the software engineering is the application of systematic, discipline, computable approach to development, operation, and maintenance of software. Successful engineers know how to use right programming language, platforms, architectures to deploy anything to form computer games to network to control systems. In addition, in building their own system, the software engineers also test, improve, maintain software built by other engineers. Now, software engineering. Software engineering is discipline that provide knowledge, tool, and methods for defining software requirement, performing software design, software constructions, software testing, software maintenance tasks. Last one is software project management. The management terms also comes in this. Now, at first, software development activities. The software development activities all include following activities: requirement analysis, design, construction, and testing. And all these terms comes under software project management. In software project management, that requirement analysis, designing, construction, testing, all comes on software project management. In requirement analysis, we analyze what the customer needs and what the customer want. And these all form the documentations form, presentation form, meetings forms. We all things discuss on requirement analysis phase. Now, after the completing of requirement, we goes on the designing. In designing, we design just form a flow the DFDs, use case diagram. Many of UML diagrams comes on this to perform design a application on the diagrams form. After this comes construction, and construction we also need with coding. In coding, we use programming language to build a program, to build a code. Now the coding is completed, then we comes on testing. The coding and testing is parallel work. Coding and testing both work on the parallel. If you deploy a code, then we test the code. If you deploy a code, we test the code. The coding and programming both work on parallelly. And coding, we use programming languages. Various programming languages in there: C programming, Java, Python, PHP, and so on. And all these management, all this work analyzed in terms of software project management. These activities do not follow strictly one after another. These activities follow after the completion of one phase, then we goes on the second phase. If, for example, if requirement is not analyzed, how we goes on the construction phase, how we would deploy, or how we would write a program. So that first we analyze the requirement. After that, we goes on the designing. In designing phase, we perform the graphs, we perform the diagrams, we perform the picture view of software. Then we goes on the construction, and construction phase is, that is coding. After the coding is completed, we test the system parallelly. Software requirement. Now we discuss software requirement. There are two types of requirement: functional requirement and non-functional requirement. Function requirement and non-functional requirement. And SRS is software requirement specification. That is a documentation that formed in requirement phase. That is SRS, software requirement specifications. Now, what is functional requirement and what is non-functional requirement? At first, what is requirement? The requirement define the functionality of system. Answer the question what, not how. Define constant on the systems. There are two types of requirement, that is function requirement and non-functional requirement. In functional requirement, we perform the functions. That means we know how the customer need and what type of software is needed, what is the requirement hardware, what is software, what is front end and back end. These all discuss on the functional requirement. In non-functional requirement, we discuss what is market policy, how it is useful. We conduct the meetings, we conduct the session, we talk on the stakeholder. All these comes on the non-functional requirement. Requirement analysis start from vision about the system. Customer do not know what they need. Customer do not know what they need, but the customer do not present in technical way. It just, we say the requirement in non-technical, just say ki, I want a software to record all the data of my shop. So these requirement in non-technical way. After technical, we conduct these all as functions. These functions are included. We want to add the product. We want to remove the product. We want to update the product. This is functional. It is technical requirement. Requirement comes roughly and are specified and extended intuitively. The terms also come is prototyping. In prototyping is often used especially for user interface. In prototyping, we conduct meeting to customer to what is the interface, what is the look of our software, what is the look of our application. The outcome is the software requirement is SRS, software requirement specifications. The software requirement specification is a formal requirement document. It describes functional requirement and non-functional requirement. In functional, business process, actor, use cases. In non-functional requirement, performance, scalability, maintenance, security, all this comes on non-functional requirement. It is always hard to describe and document the requirement in comprehensive, not ambiguous way. Good requirements save the time and money also. Requirement always change during the product. Good software requirement specification reduce the change. Prototype sequentially reduce the changes. The prototype save the time. because in prototype we discuss all the aspects of software. In prototype, it is also called a blueprint of our project. Software requirement, specification, and user interface prototype example. So now we comes on software architecture and software design. Software architecture and software design. Software design is a technical description about how the system will implement the requirement. And software architecture, the system, also called as system architecture, it describes how the system will be decomposed into subsystem, that is subsystem with module. Responsibility of, we describe the responsibility of each module. Interaction between one module to another module. We provide platform and technology. These all described in system architecture. It is also called as software architecture. Now we saw the example of our banking system. At first we see customer. In customer channel subsystem, their branch system, ATM, telephone, processing center. These all comes under the customer requirement management. The product subsystem, in product system, deposit, loan, investment. In support subsystem, customer relations, risk management, profit management. Now another external channel is mobile phone and entertained, digital TVs. These are all these has the separate modules. Customer call the call center. If any problem is raised, then how it is connected to all the system. In system architecture diagram, we detail all the detailed architectures. How we call, if I get a, for example, for banking system, we withdraw the money from SBI bank, SBI ATM from ICICI bank. How it is connected, how it is work. So all these system architecture, design architecture discuss on how this one model interact with another model, how it will be, what is the platform is used, how it is connect to on one model to another model. All these things discuss on system architecture. Now we comes on software design. Software design, detailed design, describe the internal module structure, interface, data design, and process design. In second is object-oriented design. In object-oriented design, describe the classes and their responsibility, relationship, dependencies, and interaction. In object-oriented design, we discuss all these. In internal class diagram, we describe method of class, responsibilities, algorithms, and interaction between them, that is one module to another. In software requirement, we earlier told we prepared a SRS, that is software requirement specification. In software design documentation, we perform SDD, that is software design document. The software design document is a formal description of architecture and design of system. It contains architecture design, module, and their interaction in form of diagram. For each module, process design, data design, that is DFD and ER diagram, interaction design, that is class diagram. So in that designing phase, we perform the software design documentation. In requirement phase, we prepared SRS. In software design documentation, in form prepared in software designing phase. Software design document example. Now we come software construction. Software construction, implementation, unit testing, debugging, and integrations. Now we comes on construction phase. In construction, we build a code. How we build a code? To write a code. To write a code in any programming language. Coding is the process of writing the programming code, that is we call source code. The code strictly follow the design. Developer perform internal method design as part of coding. The developer developed a code. We follow the designing phase. Now what is source code? The source code is the output of software construction process. That is written by developer. It can include unit test. What is unit testing? In a software module, there are number of modules. One person write a code, test the code. Write a code and test the code. That is unit testing. During the software construction phase, developer create a software, sometimes called implementation phase. Sometimes we also call this is implementation phase. It includes internal method design, writing code, write unit test, testing and debugging, and integration. What is testing and what is debugging? Testing is the process to write the code and test the code. Debugging, we create a software and we used number of people to find a bugs. That is debugging. What is integration? The integration, this is also integration terms on testing. One person developed one model and test the code. Another person developed model second and write the code and test the code. If both, and we earlier say one module depend with another module. If both module tested, that testing is called integration testing. Testing check whether the developer developed the software conform the requirement or not. In testing, there is two terms. At first, we write the code, we check any error, technical error is come or not. After that, we check developer develop the software that conform the requirement or not. And that phase aims to identify the bugs. Developer test the code after write it. At least run it to see the result. Unit testing is even better. Unit test can be repeated many times. If you find the debug at the unit testing, then it is easy to find the bugs in unit testing. If we do not find the bugs in unit testing, then bugs comes on integration testing. That is difficult to release the bug. System testing is done by QA engineer, that is quality assurance engineer. Unit testing is done by developer, and integration testing is done by quality engineer, that is QA engineer, quality assurance engineer. In quality assurance engineer, check the requirement, conform the requirement or not. In QA engineer, check if the developed software is conform the requirement of customer or not. Unit testing is done by developer and integration testing is done by QA engineer. Now debugging. Debugging aims to find the source of already identified defect and fix it. It is performed by developer. Steps in debugging: find the defect in code, identify the source of problem, identify the exact place in code that where the bugs comes, fix the defect, test the code and correct this. These all comes on debugging. This is the steps include in debugging. Now integration. Integration is putting all the pieces together. That means we put all the module and assemble it and test it. That is done by QA engineer. Compile, run, deploy module as single system. In integration, all module assemble it and work as a single system. Test to identify the defect. Integration strategy, big bang, top down, bottom up, and continuous integration. These are strategies used in integration testing, and this testing is done by QA engineer. The one term is coding is not equal to software engineering. How coding is not equal to software engineering? Inexperienced developer consider the coding the code of development. In most of project, coding is only 20% of project activity. And what is 80% work? In 80% work, become requirement, designing. These all comes on 80% work. The important decisions are taken during the requirement and analysis and designing phase. Documentation, testing, integration, maintenance, etc. are often disappeared. Software engineering is not just a coding. That's why programmer not equal to software engineer. A good programmer become also write a, also describe a requirement of customer, also design a document. Now we comes on software verification and testing. What is software verification? It checks whether the developed software conforms the requirement of customer or not. Performed by software quality assurance engineer, that is QA. It used two type of approach. Formal review and second is inspection. In formal review, he checked all the model work together or not. If our software fulfill the requirement or not. Inspection, we randomly verify the code. Different kind of testing. That is, we earlier test unit testing. That is, unit testing is done by coder, developer. Integration testing is done by QA engineer. Module testing, system testing. There are different kind of testing is come. We cannot use absence of defect. Can only decrease the rate. What is software testing? Testing check whether the developed software conform the requirement of customer or not. Testing aim to find defect, that is bugs. Black box and white box testing is also done. Unit testing, that is done by developer. Integration testing, that is done by QA engineer. System testing is also done by a QA engineer. And acceptance testing is done, checked by customer. There are these different kind of testing. Stress test, load test, regression test. Tester engineer can use automated testing tool to record and execute the test. After construction phase is completed, then the testing phase is going on. And in testing phase, if you take one month for developing a code, then 1.5 month take to test the code. Because testing is too much important, because Testing is if software does not fulfill the requirement of customer, then our customer do not accept our product. So that's why the testing is also work parallelly, and it takes more 1 point more. If we take 1 month for developing the code, then 1.5 months to take the testing the code. After that, the beta testing, alpha testing, there various kind of testing is come. What is that software testing process? Test planning. In test planning, we establish the test strategy and test plan during the requirement and designing phase. Test development, test procedure, test scenario, test cases, test script. Test procedure, they are the provided, and standard test procedure is there. Test scenario, we create the scenario to test the code, test the product, depend on the product. What is test cases? Test cases is written validations, validations process that are used developer. That's why we write a test cases and test the code. Test script, test execution, test reporting, and retesting the after last. We also retesting the defect, and we if any bugs is comes, then we check and fixed it. After that, again we test the whole testing process. It take 1 to 2 to 3 times. Then we stop the testing. Then we forwarded that product, that code into that product into team, and whole team member test the same code number of times. Test plan is a formal document that describes how test will be performed. List of test activity to perform to ensure meeting and requirements. Features to be tested, test approach, schedules, and acceptance criteria. Test scenario and test cases. Test scenario, story to be tested. In test cases, test of single functions. Test plan and test cases example. Now, we comes on software project management. That is project management. Project management is the discipline of organizing and managing resource in order to successfully completion of project. Successfully means within the defined scope, quality, time, cost, and constant. Successfully means scope. What is scope? That is what the requirements should be given by the customer, that is fulfill or not. Cost, we use minimum cost to deploy the software. Time, we need to meet the deadline. Quality, and project status. These means the successful completion of project, and these all managed in software project management. Software project management is a discipline about planning, monitoring, and controlling our software project. Now, project planning. In project planning, we identify the scope, estimate the work involved, and create a project schedule. In project monitoring and control, we keep the team up to date on the project progress and handle the program. If we monitor the project time to time, then our deadline should be met. Project plan is a document that describes how the work on the project will be organized. Content, task, resource, schedule, milestone, etc. Task have a start and assigned resource. That is assigned resource matlab team member. Percentage of completion, dependencies, nested tasks, etc. Project management tool simplify creating and monitoring the project plan. And project plan is also form a documentation, that is we saw in example, that is project plan. There all the steps of project should be there. We also, after the deploying the, after the designing is completed, we create a project plan. How much time to take one module one, how much time to take create of module two, because if this not prepared this project plan, then we not deploy a successful software, because dependency of module, modules depends on another. That means the one person's work is depend on the another person's. If we do not monitor, do not take the major step and that make the plan activities, then our software should not meet a deadline. Now we comes on development methodologies. Development methodology is a set of practice and procedure for creating a software. A set of rules that developers have to follow. A set of convention the organized scribe to follow. A systematical engineering approach for organizing a project. Now, software development methodologies. At first, waterfall process. The old process, that is waterfall process, not used today, because today we work on the real-time system. Rational unified process, that is very formal, lot of documentation is needed. Microsoft Solution Framework, that's MSF, that is formal or heavy weighted approach that's we used in nowadays. Now, waterfall development process. What is waterfall development process? They are the models. In that way, we developed a software. At first, software requirement. The first phase is software requirement. In software requirement phase, we prepared a SRS. That is software requirement specification. In SRS, we discuss, we describe, we detail information of requirement. Now, software design. In software design, we create SDD, software design documentation. In software design documentation, we use diagram to overview and design of complete software. Now, after that, we goes on the implementation phase, that is coding. In coding, we all have, we write a program by using any programming language, and that we comfortable that platform you used. After that, we comes on the verification phase. That is verification also comes in testing. In testing, we write a code and test a code, and there are various type of testing is there. Now, operations. There is operation and we also call it maintenance. And the maintenance phase is still work, their project is alive. If any changes we want to update, then we goes on the software requirement phase and again follow the same process. That's why these development process is too old and too much time taking. Nowadays we use spiral method, and that method we used MSM is just microforce heavy weighted framework. In that way, we work parallelly. And formal methodology for heavy weighted, that is example of heavy weighted, lot of document and diagrams is there. We see requirement, system requirements, software requirement and specification, preliminary design document, UI document, all has a interrelated to each other. That is the for heavy weighted methodology, and lot of document and diagrams is used there. Thank you.